So proceeding on to the next question, a diagram shows a resistor network. Okay, the potential difference between X and Y is given to be 8 volt. Okay, so we need to find out the current in the 5 ohm resistor. So suppose the potential of the point X be Vx and the potential of the point Y be Vy. Okay, and what they have given that Vx minus of Vy is nothing but your 8 volt. Okay. Now let us suppose the main current in the circuit be I. Okay, at the junction X the main current is getting divided into two subparts. Okay, one is your I1 and the other is your I2. Okay, now the I2 is flowing through the 5 ohm resistor. Again the I2 is also flowing through the 3 ohm resistor, right? And it is finally coming to the junction Y. Okay, and for the current that is I1 is also flowing through the 3 ohm resistor, right? Then the I1 is flowing through the 1 ohm resistor and the I1 is coming to the Y joint. Okay, so over here after coming to the Y joint they both get combined and leave as I. Okay, so this is the distribution of current in the resistor network. Okay, so now if I just take the I2 resistor network, what will we get? See, over here this is I2. Okay, the potential of this point is Vx. Okay, now I2 is passing through your 5 ohm resistor, right? So the 5 ohm resistor is given by a box, but I am changing it to a resistor form. Okay, so over here it's passing through the 5 ohm resistor. Okay, after that it is passing through the 3 ohm resistor, right? See in the figure. Okay, again after that what is happening, it's going and meeting the Y. Okay, and the potential of the point, so this is the Y point, right? And the potential of the point Y is your Vy, right? This is the Y point and this is the X point. Okay, so over here if I just write Kirchhoff's law for the sub circuit, I can write that Vx, okay, the potential at the point X is your Vx. So the current I2 is flowing through the 5 ohm resistor, right? So that means if I just go in the direction of the current, what will happen? Potential drop will take place, right? So that means Vx minus of your 5 times of I2. Okay, now again I am going in the direction of the current. Okay, so that means what is happening now? Again the I2 is passing through the 3 ohm resistor, so I can also write minus of 3I2, right? Again I am going in the direction of current, so what I am doing is that I am traveling from X in the direction of current. Okay, so what is the potential at point X? Vx, right? So after point X the I2 current is flowing through the 5 ohm resistor and we are going in the direction of current, so net potential drop will take place, which is I times of R, which is 5 times of I2. Again I2 current is flowing through the 3 ohm resistor and we are going in the direction of current, so net potential drop again will take place, right? And finally by traveling in the direction of the current we reach the point Y, right? So that means at the point Y what is the potential? Vy. Okay, so this is the basic Kirchhoff's law for the sub circuit. Okay, so over here I can write that Vx minus of Vy, so this will be equal to your 5 times of I2 plus 3 times of your I2. So over here I can write that I2 will be equal to 1, right? So that means over here 1 will be equal to your I2. Okay, so that means we got the value of your I2. Okay, so what is the current that is flowing through the 5 ohm resistor? Right, I2 is the current, right? So this is the current only that is flowing through the 5 ohm resistor. Okay, so that means the correct option to your question number 19 will be option number A, 1 ohm. I hope you got the question. So proceeding on to the next question, that is your question number 20. When a wire with an electric current I is placed in a magnetic field B, it experiences a magnetic force F. Over here we know that the force is nothing but is equal to your L into I cross B, right? So this is the magnetic force. Okay, so over here L is the length of the wire, right? I is the current that is flowing through the wire and B is the magnetic field of strength, right? So in order to find the direction F, we need to know something about cross product. Okay, suppose there are two vectors, okay, A vector and your B vector. Okay, so suppose A cross B is equal to your C vector. A cross V is equal to your C vector, right? So that means over here C vector is both perpendicular to A vector and B vector, right? So C vector is both perpendicular to your A vector and your B vector. So this is the definition of your cross product, right? So that means C vector would be perpendicular to A vector and C vector would be perpendicular to B vector, right? And we also write this, that C vector actually lies in the plane that is perpendicular to A vector and B vector. Lies in the plane that is perpendicular to A vector and B vector. Okay, so this is the definition of your cross product, that is the direction of C vector which is formed by the cross product of A vector and B vector. Okay, so this is the standard definition of the direction of C vector, right? Now over here over here we can write the force vector as L times of I cross B, right? So that means over here what we can say? We can say that F vector will be perpendicular to the direction of the current and F vector will be perpendicular to the magnetic field strength also. So that means over here we can say that F vector will lie in the plane that is perpendicular to your I and B. So that is perpendicular to your I and B, right? So that means over here we can say that the force vector will be at an angle 90 degree to the plane containing I and B. Okay, so that means the correct option to your question number 20 will be option number D. Okay, so let us explore the other options also. Option number A says that in a direction determined by A only. No, it is not true. See, F is perpendicular to I, okay, but F is perpendicular to B also, right? So that means it is also determined by the direction of the magnetic field strength B. So this is the incorrect option. In a direction perpendicular by B only. Okay, so this is the first question only. Okay, see, it is true that is determined by B, but is also determined by A, right? So that means B is incorrect. Okay, in a plane containing A and B. Okay, what is the definition? Go back to the definition. The definition says that C actually lies in the plane perpendicular to A and B, not in the plane of A and B. Okay, so that means this option is incorrect also. The correct option to your question number 20 is option number D. I hope you got the question.